Oh, hey guys, what's up? Let's see here. So, starting new topic. We're actually skipping to 8. Woohoo, so exciting. Yeah, let's see. So, this is like a geometry unit. So, we're going to talk about scale drawings today. A lot of times you'll see this, I don't know, blueprints when you're like looking at a house or something like that. If you're an architect, you will make scale blueprints all the time. In construction, you'll use these all the time. I don't think well, I don't know, you might be making them in construction as well. Not really sure. But anyway, so we've got this actual plane right here, which is 240 feet long. Okay. And then this kid, Calvin, made a scale model of the plane as shown, which is 15 inches long. So, how can you represent the relationship? Ooh, sorry, guys. Between the model of the plane and the actual plane. And then we're going to set up a ratio to do this, right? I've got let's see, x is going to represent our variable here, and that's going to be the number of feet per inch. That's kind of a weird way to say it because you would normally it's like 12 inches per feet. But scale drawings, right? It's like shrunk down, and it's meant to represent like a real thing, right? So, but it's smaller, so you got to like have a scale that kind of matches them to it, right? So the idea here is we're going to have that 240 feet of the original plane matching to 15 inches of the scale model, right? 240 to 15. And we want to figure out x, the number of feet per inch. And that's going to be represented by 1 inch right there. Basically, per 1 inch, we want to figure out how many feet is it. Okay, so we're going to multiply here and then across. So 15 times x. Right? I don't know if you guys remember the butterfly methods. That's not 25, that's 15x equals 240 times 1 is 240. And we'll divide by 15. If you have a calculator, you'll get to x equals 16, 16 feet per 1 inch. And that is our answer for that. And so what do you notice about the relationship? Well, so like 1 inch is 16 feet, 1 inch is 16 feet, 2 inches would be 32 feet, 3 inches would be 48 feet. So the relationship is proportional. And that'll come in handy later when we start putting these into linear equations. Okay, proportional just means that if you drew a line for it, it'll go through 0, 0, it'll go through the origin, and it has a constant rate of change. Like the x values go up the same as the y values. Or not the same, but the x values increase by the same number or decrease, and then the y values increase by the same number or decrease. All right, the kitchen island in the blueprint is 6 inches long. Kaboom. What is the actual length of the island in the kitchen? So we've got our scale down here as 1 inch is equal to 1.5 feet. Did the work earlier, so I don't have to think when I'm doing the video. We've got going to set up our ratio right here, our proportion actually, because these are proportional relationships, equals x feet over 6 inches. And x is the length of the island. If you're ever wondering, like, man, how did Mr. Wishart come up with what that x is equal to? Well, look at this. What is the actual length of the island in the kitchen? That's where I get it. X is equal to what you're looking for, right? Or your variable is equal to what you're looking for. So you do the same thing. We cross multiply. Here, 1x is the same thing as just x. 6 times 1.5 is 9. Okay. So we get, 9 feet. Okay. So 9 feet is the length of the island. If I could write of the island. Okay, and then similarly right here, we're going to set this up. However, instead of having 6 inches, we're going to have 2.5 inches. So it's going to be the same proportion. So 1.5 feet per 1 inch is equal to x feet over 2.5 inches. Okay, and so cross multiply again. So we get x 1x is the same thing as x. And then 1.5 times 2.5, just put that into a calculator. We just multiply, right? That gets us to 3.75 feet. And that's the length of the island if the scale drawing were 2.5 inches instead of 6 inches, right? So basically, if it were like 2.5, like right there. Okay. What is the area in square yards of the deck represented by this scale drawing? So we have 8 centimeters on the drawing and 16 centimeters this way, and the scale is 1 centimeter per 2 yards. So the equation we're going to do for this is y equals kx, right? And y equals, I'm running out of room right there. Y equals kx, and this just represents a proportional relationship, okay? And proportional. Man, I can't spell today. Might be kind of hard to write that. Just kind of wing it. Okay, proportional relationship. Proportional. Okay, so what we're going to do, we're going to break this up into steps. Step one we find the actual height of the deck, or height on the drawing is represented by this. So find the actual height. Okay, now we're going to plug it in here. That K is going to be the scale. So we're going to be multiplying by 2. Okay, so we're going to have the actual length as that big L equal to the scale factor, which is that 2 multiplied by the little l, the original length right here. Okay, so it's going to be the big L, the actual height. Did I screw this up? Find actual length, not height. My bad. Sorry. Find actual length right here. So it's going to be 2 times 16. Okay, that's the length right there. So that's going to be 32 feet. And then step 2 is going to be finding the width, find the actual width. And we're going to set it up the same way. It's going to be big W is equal to 2 times little w, which in this case is 8. So that's 16 feet. So then step 3 is find the area. An area for a rectangle is just base times the height or length times width, whatever it is. It's going to be 32 times 16, which, just so that no calculator, that's going to give you an area of 512 yards squared. Right? It's important to use that squared because it is a two-dimensional shape that we're looking at. Okay. Okay. Students are recreating a landscape drawing for a mural. They want the length of the drawing of the mural to be 80 inches. What will be the new scale and the height of the drawing on the mural? So we're going to break this up into steps again here. Step 1 is find the actual measurements. So we're basically going to take step 1 and step 2 and combine them into step 1. Find the actual measurements. Okay. And so the length is going to be the scale factor times the scale factor is 4 right there. And so it's going to be 4 times 10 for the length. And I can't talk. So that's 40 feet, which is gigantic for a mural. And then the height, height, is that what I want to do? Width, I don't know, either way. It's going to be, let's do height actually. So the height of the mural is going to be 8 times that 4. So 32 feet for the height. Okay. And then now we want to find the new scale because, again, they don't want it to be the length. They want it to actually be 80 feet, right? So we need to kind of change the scale on it, alter the scale. So step 2, find the new scale. And the idea here is we're going to set up a proportion. We've got 40 feet for the original length. The desired length is 80 feet. And then we're going to have that x equals 1 foot. Okay. And x is going to be the new scale. And so we kind of multiply across here. We get x equals, actually 80x equals 40, right? Gosh, 80 times x is 80x, 40 times 1 is 40. So we divide by 80. Man, I'm running out of room here. And then we get x equals either 1/2 or x equals 0.5. Either way, that's our new scale. And so then we're going to find the new height using the new scale. So that's step 3. Find new height. And the idea is basically we just take half of that original height of 32, right? So if the height is 32, um, it's just going to be 32 equals 0.5 times the new height. So we divide by 0.5, and then that gets us to 64. 32 divided by 0.5 is 64. Okay. And so then I'm running out of room here. What is it looking for? What will be the new scale and the height of the drawing, right? So the drawing height is 64 feet. Yeah. Mm-hmm. There you go. So your dimensions are going to be 80 by 64. So that's the idea. Okay. There you go.